scientists have been able to draw power from the room temperature thermal motion of graphene, which gives us an unlimited source of clean energy for small devices in the future. The approach cleverly uses both the nanometer size fluctuation found in graphene and Brownian motion, the random motion of particles, to produce an electric current that can be presented to a variety of uses. An energy harvesting circuit based on graphene can be incorporated into a chip to provide clean, unlimited, low-voltage power for small devices or sensors, says physicist Paul Thibodeau. The origin of these nanometer-size fluctuations is still an open question, he said, noting that the graphene fluctuation appears to be due to subatomic particle interactions in the material. A significant part of the development of their system was to use two diodes in the circuit to convert the original alternating current AC to direct current DC. This allowed the current to flow in both directions along separate paths along the circuit. The resulting result is a pulsed DC current that can operate on a load resistance and potentially operate small electronic devices. Another finding was that the two-diode design of the system helped increase the amount of power supplied. What the research shows is a symbiotic setup between graphene and circuit, which avoids conflict with the second law of thermodynamics by maintaining a single uniform temperature so that heat is not transferred. In other words, the current flowing in the resistor does not heat it. It owes much to stochastic thermodynamics, a relatively new field of study that looks at macro and micro interaction in systems when it comes to energy and heat interaction. The slow motion of graphene means that current is induced at low frequencies in the circuit, and this is important for efficiency. The next challenge will be to figure out how to deploy and use the system in a practical way to find out if the system can be stored in a capacitor for later use.